back to another AnyRPG Development Livestream. In these videos, you can watch the live development of the AnyRPG Engine, a free and open source role-playing game engine designed in Unity and written in C#. If you don't already have a copy of AnyRPG, you can pick one up from anyrpg.org/downloads in both Unity package and source code format. You can also find at the same page A Lost Soul, the free playable game that I work on in these episodes. In this episode, we will be adding some new features to the engine. I've been improving the scaling, and in the last episode we added the ability for items to scale up to a certain level cap and for their price to scale up and down based on quality and level. And in this episode I basically wanted to add scaling to our mana costs. Essentially our mana cost for our spells is just sort of fixed, and it just becomes super trivial over time. And managing the mana cost for spells is a little bit of a hassle right now. And so if you see here in the game, what we've got here is my character, who is a channeler, and you can see he's got mana as a resource. And then we have over here a warrior trainer, and he's a warrior and he has mana as a resource. And we have this fighter trainer over here, which is kind of bugged, but if you see when I click on him there really quickly, he's also got mana as a resource. And over here we have our huntress, a really cool huntress here, who's our ranger trainer, and she also has mana as a resource, and she's also like a ranger. So in order to automatically scale the mana usage of a spell, or the mana cost of a spell, as your mana pool grows, we basically need to scale or to set some scaling values the same way that we did for the items. So if you look at any of our items, like for example our ancient plate, boots right here, and we can scale every item level. It'll add 10 silver to the cost. But we don't have that for spells. So if you look, for example, at our Solar Singe ability right here, we do have a mana cost. It costs 10 mana, but that cost never goes up over time. So I want that cost to scale. Like since the damage of the ability scales as you go up, or has the potential to, I want the potential for the mana cost to scale. And then this way you can have spells that basically sort of auto rank up, like they become more powerful over time and more costly over time, and then that way you don't have to manage a whole pile of different spells with different like mana costs and such. So let's go ahead and add that, but in order to add the ability to scale, I don't want to hard code mana into the cost. Because basically, like, what happens when you have like rage and energy? So we might as well just add rage and energy to the game right now. And then any resource can be defined. It's not going to be hard coded. We won't assume you have mana in your game. Maybe you don't. Maybe you have no resources. Maybe you have energy. Maybe you have rage. Maybe you have focus. Maybe you have some other crazy thing like holy power or like ability combo points or something, right? So we can do that. We'll have to create a new type of scriptable resource for that. And that scriptable resource is going to be called the PowerResource class. So we're going to go into our engine directory here, into our game manager, and into our resource profiles. And the closest thing that I have to this right now is the item quality, because this one defines a color, and we're going to define colors for our power resource. So our rage will be red, our energy will be yellow, and our mana will be blue. So this new class will be called the power resource. And we're in the power resource script here, so we're going to change this. So the public class name is PowerResource. I've just duplicated an existing script that was close enough to this, and we'll call it new PowerResource and AnyRPG PowerResource. And I'm going to have to clean this up eventually, because if you go into the game here and you go create AnyRPG, this list is getting hugely long, so I'm going to have to do better on the subcategories. But for now, we'll just put it at the base level. And now we've got the PowerResource class. So then we'll need a way to access power resources when we're in the game. So to do that, we will create a new type of resource manager and stick it on our game manager. So we have already the system item quality manager, and since we duplicated item quality, we can duplicate the item quality manager here and rename that to system power resource manager. We'll change that to system power resource manager. Make sure we've got the right thing open here and call it system power resource manager. We'll double click that and change the names of the singleton here, and then fold up the singleton region, and the resource class name will be power resource. We're going to find all instances in this script of item quality and replace that with power resource. And then we'll add this to the game manager. And this is basically our factory that in the future will allow us to access these things through a database as well. It's just a nice generic way to get to the scriptable objects, so we're not necessarily tied to scriptable objects. So let's open this thing up here. Also, it's capable of like resetting resources if we have ephemeral properties on them. So we will add the system power resource manager here. That looks good. And now we've got a way to access these things. We'll let our game manager save there. And now let's go ahead and make a power resource or two. So we'll put these under a lost soul shared because these aren't tied to any specific like prefab or anything like that, so we can redistribute these. So we'll create a new folder here, and that folder will be called power resource. And we'll go into the power resource folder and create AnyRPG power resource. And the first one we're just going to call mana. Set the resource name to mana. And for the description, I don't know, used by channelers. What we want is a quality color for it. So I like that blue that's currently on our unit frame. So let's go into the unit frame. We'll go into the scene mode here. We will click on this. We will copy that nice, beautiful blue color there. We'll pop out. We will go back into the mana power resource. And I'm just going to put power resource on the end of this name here. The name of the file doesn't matter, but that'll help us search for it a lot easier. Then I'm going to right click and paste, and it's now a nice blue color. Actually, what I need to do, that's not a quality color, that's a resource color. You know what? No, that's the display color. Yeah. Let's save that, and I'm just going to actually paste that value back in because I think it'll reset to black. Nope, we've got some errors in the console here, right? Of course. So this needs to say display color. Okay, we'll let that reset here. And paste that again. Okay, great. So now we've got a nice display color. We don't need this box require cell confirmation because we can't sell PowerResources. We don't need price multipliers. And let's see. What I would like is to define in combat and out of combat regeneration levels for this. Like, because energy should regenerate. So why don't we make a new float here, and we'll call it regen per second, and the amount of this resource to regenerate per second while out of combat. And then we'll have combat regen per second. And also we'll need a header for this as well. Regeneration. And the amount of this resource to regenerate per second while in combat. Okay, that looks good. And then let's see what else we need for this. I guess that's good for now. Actually, this can say display color. And then we'll just make these fields available as well. And we'll make a new header here. And we'll call this display. Okay, that looks good. That's a lot better. Now let's see what this looks like in the inspector. And then we should have a nice power resource here. Okay, good. Display, display color, regeneration, regen per second, combat, regen per second. So now we can, let's see, go into the power resource folder, and we'll Control D to duplicate that. Control D again, make another one, and we will call this one the energy power resource. And we'll call it energy, and our display color will be yellow, and the regen per second, let's do 20, and then combat regen per second of 10. Alright, so this one will basically just sort of fill up over time. At least that's the idea. Alright, and then we also want for our warriors a rage power resource. Rage, call this used by warriors. Call the energy used by fighters. And we'll set our rage power resource to a nice red. That looks good. And rage will not regen, basically. Okay, so for the mana power resource, we'll have combat regen per second as 0, and regen per second as, I'm not even sure what we have as the regen per second. I'm going to leave that for now because we already have like a regeneration for the health mechanic, and I just want to see how that works, basically. Okay, so next thing we want to do is we actually want to tie these resources to classes. So let's go look at the warrior class. This is the warrior class description. This is the warrior class description. So we want to look for just the warrior class. And I'm just going to call that warrior class so it's a little easier to search for. Ranger class, fighter class, channeler class. Okay. Here we have weapon skills, ability names, trait names, armor classes, power enhancer stats. And stats per level. So let's add resources. We'll add power resources as a list. So at the very top of it, add a new header. Call it power resources. Add a new tooltip and power resources available to this class. You know what? Used by this class. And let's see. The first resource is considered primary and will show on the unit frame. We're going to change that up in the future. We might do something like combo points or something and have them like a secondary power resource display, but for now we'll just have the first one automatically shown on the unit frame and nothing else really displayed. But we will put in the ability to put a list so we don't make a breaking change later. So basically this is a new private list of power resource called, no, you know what, this is a private list of string because we're going to grab these from our factory. Power resources, and that's a new list of string. Okay, and then we need a private list of power resource called power resource list. Make that a new list of power resource. And it's a reference to the actual power resources. And then in our setup scriptable objects method, we'll have to turn these names into references, so through our factory. Here we have real ability list. I think I can just rename that to ability list. I like that a little better. No conflicts, good. And here we'll say the same thing. It's just a reference to the actual ability. We'll put a tooltip up here, letting our user know that abilities available to this class, and another tooltip, weapon skills known by this class, and then a reference to the actual weapon skills. And I think I'm actually going to do a formerly serialized as here. And it was formerly serialized as weapon skill list. In order to be a little neater in our inspector, we're going to call that weapon skills, and then this way we can call this weapon skill list. We're going to have to rename that, otherwise we're going to get errors. Okay, good. So then trait names, go tooltip, and traits are traits are basically status effects, which are automatically active at all times if the level requirement is met. And I'm going to rename that to trait list. And then armor class list, we'll add a new tooltip for that as well, to let the player know that armor classes that can be equipped by this class. And I think that's good for now. I'm going to change these resources later. So next thing we need to do is go into Setup Scriptable Objects and turn those references into, or those names into actual references. So we need to set the power resource list is a new list of power resource, and if power resources does not equal null, then for each rename this to power resource name in power resources, grab a reference to a power resource, rename that to TMP power resource. We will grab from the system power resource manager.myInstance.getResource based on the power resource name, and we will add to the power resource list the TMP power resource. Otherwise, we could not find the power resource while initializing this. For here, this actually we want if weapon skills does not equal null, then for each weapon skill name in weapon skills. Okay, that looks good. So now let's just go back and check if we have any errors in Unity yet. Okay, good. No errors. So then, under the power resources, the warrior will have rage available to it. And I think I'm going to call this channeler character class. Okay, so then the channeler will have mana available, and the fighter, let's just update the names on those. So fighter class description, this is the fighter character class. So our fighter character class will have available energy as a resource, and then let's see, our last class is the ranger. For now, I'm just going to have the ranger use mana. I'm not going to implement like focus or anything like that yet. So the ranger will just use mana. Okay, there. So now that all these guys have their character classes, so this is good basically because we already have an intellect to power ratio. No, just a second. We have intellect to crit and intellect to spell power. Intellect needs to be translated into mana at some point, and I think that's actually just happening internally automatically. I don't think we're defining that. That might be defined in the game manager itself. Let's just see. Yeah, you know what I think? That's an internal assumption, basically, that your stamina is being translated into your health at a rate of 1 stam equals 10 health, and that your intellect is being... No, wait, you know what? I think that's got to be a... Yeah, that's an internal assumption of the engine. Okay, great. So we'll have to we'll basically need to expose that that assumption somehow. So let's see. Now what we need is basically for our abilities to be able to choose a resource to use and a resource amount per level. So we'll go into the base ability, and somewhere here we have ability mana cost. We need to change this. Let's see, so we'll start with a tooltip here and a serialized field, and we will make a protected string, and this is going to be called the PowerResource, I guess. You know what? Resource name. And actually, let's see. We also need the ability to generate stuff, but we're not going to get that from abilities. We'll get it from ability effects. Essentially, we need to be able to generate rage on hit. So let's see. For now, at the ability level, not at the ability effect, this is just the resource to use up when casting this ability. So then we want the resource cost, and we'll do actually two things. We'll do base resource cost, and this is a fixed amount of the resource to use per cast, and then we will do another one called resource cost per level, and let's see. What I want is for most abilities, you should be able to basically, like if you're using mana, for example, you should be able to cast like 20 abilities before you run out of mana at any level. So essentially, since you're basically getting 100 mana per level, that means you should be using like 5 mana per level. So the resource cost per level by default will be 5. Essentially, that means all abilities by default, unless otherwise, will use 5% of your total resources at any level. And this is kind of like tilted towards mana, because obviously you don't want rage to scale, or energy, actually. Okay. So then we'll want probably a reference to the resource. So we'll make a protected power resource and we will get a reference to that in our set Up Scriptable Objects. So our power resource is null, and if our power resource name resource name. And actually, you know what? I feel like resource name is actually a field of describable resource. It totally is. And I'm just overwriting it, I think. So we'll have to use actually PowerResource name then. Okay. So then if PowerResource name does not equal null and PowerResource name does not equal string.empty, then PowerResource TMP PowerResource equals system PowerResourceManager.myInstance.getResource based on PowerResource name, and if TMP PowerResource doesn't equal null, then our PowerResource equals our TMP PowerResource. Otherwise, we could not find the PowerResource. PowerResource name while initializing this ability. Okay, so now we've got some changes we need to make here. We have my ability mana cost. We need a ability resource cost. And the resource cost needs to actually be based on the character that's going to be casting it. So we're actually going to have to remove this. Let's just see if we've exposed, we haven't exposed the power resource yet, I don't think. So we'll expose the power resource. And we'll make a new function called getResourceCost. So this will be a public virtual float getResourceCost. And for here, we will need basically the level of the character, which is going to be the I ability caster, and so our resource cost is comprised of the I ability caster's level multiplied by the resource cost per level plus the base resource cost. So base resource cost plus ability caster dot level multiplied by the resource cost per level. And we're only going to do this if our ability caster does not equal null. Otherwise, we're just going to return the base resource cost. Okay. that is going to generate a whole pile of errors. Or just one. So we will remove my ability mana cost. We will expose a PowerResource, making it a get only. Then we will make a new function, which was a float. Get resource cost, taking an iAbility caster. Now we should have some broken references. Base ability dot PowerResource cannot implement an interface member because it is not public. Oh, this is protected, that's why. Okay, that's better. Let's see, any more errors? Now we should have everywhere where we were referencing a fixed mana cost. We now need to reference something else. So, starting with right here. This is mana, and we need to change that. So, two will be a variable, and that's going to be the resource name. I think actually we'll make like the entire thing just called cost string, because an ability could potentially just not even have a cost. So we'll make string cost string equals string.empty. Then if PowerResource does not equal null, then cost string equals, and this is a summary, so it's safe to basically assume that it's the character, because NPCs can never see the summary. They don't have mouses to hover over stuff with. So our cost string is /n cost xyz resource. Number two will just simply become cost string. And the cost will be the PowerResource.myName and then the actual resource amount which is the PowerResource.get. No. We want our ability.get resource cost. Our own resource cost, sending in the character. So player manager.myInstance.myCharacter.myCharacter, or whoops, dot character ability manager. Okay. Great. So then now we should actually properly display whether this is rage or basically anything on our mouse over descriptions. So let's find the next reference to where we were specifically referencing mana cost. Okay. Here we have perform mana check. Let's rename that. Actually, you know what? Let's go down to the base. And we're going to rename this to perform power resource check. And it's public, so let's just give it a summary that says check if the caster has the required amount of the power resource to cast the ability. And here we have current mana. So this is where we've got the idea of mana like hard-coded in the engine. So let's go ahead and remove that assumption. We'll go less than ability dot get resource cost, and this is a character ability manager, which is already an ability caster, so we can just send in this. Okay, now let's go to the current mana definition. So here we want to change this. We don't want current mana anymore. We want a list of resources. So let's go make a private list. Actually, this is going to be a dictionary, because basically what we want is a dictionary that's going to tell us a power resource and an amount. The amount can be, we'll just make it a float, I guess. So this is a private dictionary of power resource float. And we will call this the power resource dictionary, creatively enough. And that's a new dictionary of power resource float. All right, so then I guess what we want to do is that's where we'll be retrieving the stuff from, so we can't grab current mana anymore. We'll be grabbing it from this dictionary. So the dictionary we'll have to set when we set the character class. And let's see if we can find the code for set character class. I think that's actually in the player manager. Okay, so let's look at the player manager. class? No. Was it change class? Change class, change character class. There we go. Perfect. Okay. So we'll go to the definition of change character class. And then we cast set character class, which is part of the player character. And we're going to go down to the base definition, which is part of base character. Okay. So character class is stored on a base character, but I think we'll store the resources on character stats. So we have character stats.setLevel. What we'll also want is before that character stats.set character class, accepting the new character class. So then we'll want to actually make a method to accept that. So we'll go into character stats and we will make a new public void set character class, accepting a character class, And what we will do is create a new PowerResource dictionary. Actually, not create a new one, just overwrite the existing one. And then we'll add to it. So for each PowerResource in and we want to check the character class dot, and let's see, I don't think we're exposing this. PowerResource list, we'll expose that. And then what we'll do is we'll basically set the PowerResource dictionary dot add with the key being the PowerResource and the amount just being 0 of that resource for now. And then now we've got a reference to all the power resources. Okay, so now we can actually perform a check. I think what we'll do is we'll actually just pass this in as a function and have it perform a dictionary lookup internally. So here, let's see, will we accept the I ability or do we want to accept instead we're going to accept just the cost. We're just going to send that in. So this is a float. So basically we'll accept a float resource cost. And you know what? We actually do need to send in not only the ability cost, but the actual ability as well, so that we can get its resources. So this will be perform power resource check. Sending in the ability. We'll return false by default, return true if the check passes, and ask it to compare against the resource cost. So we'll accept iAbility and float. So iAbility and float resource cost. And first we want to check if our dictionary has the ability's resource cost. So if our PowerResource dictionary contains key, grabbing the power resource, so this will be ability dot power resource. And if it does, then if our power resource dictionary using the ability dot power resource as the key, retrieving the value of it, which is the float, is greater than the resource cost, then we have enough. Otherwise we don't. And actually we can basically just simplify that into a AND statement right here. And now we can check if we've got enough resources for that. Okay, awesome. So then let's go and find any more references that were hard-coded to mana. Now we have a pile of them. So what we need now is basically, here in the unit frame, we're tracking on mana changed. And what we should actually be tracking is on resource changed. So we need a way to list the maximum resource amount. So for like fighter, for example, the maximum resource amount of his energy should pretty much like always be 100. And with a warrior, let's set the maximum resource amount, like the rage amount, at 100 as well. So to do that, we'll edit the PowerResource class, and we will set a maximum amount for the resource. We'll just put it under a header called like limits or something for now. And we'll make a new serialized field, and this will be a private float maximum amount. And let's see, in this case, we'll add a tooltip letting the user know that if this amount is greater than 0, the resource has a maximum fixed amount. And then we should expose that. All right, so for energy and rage, we'll set the maximum amount to 100. And actually, we won't be able to see that because we have like all these other issues right here we're going to have to fix first. Okay, so we won't quite do that yet. For mana, we need a different way to determine the maximum amount. So let's see how we're going to do that. Basically, this resource needs a way to know that intellect, for example, is going to give it a higher amount per level. And this is currently handled right. Fix this issue right here. Okay, this is currently handled in character stats. When we set the character level, there's a bunch of stuff we do, I think down here. Right here. We set our intellect, and then we calculate our primary stats. And then we calculate our intellect. And then we get our current intellect, and then we reset our mana, which is based on our intellect. And if we go to the definition of my max mana, there we go. This is that hard-coded assumption right here. Okay, so this number right here, not everybody needs mana, so this calculation right here can't be like basically baked into the engine. We need this calculation to come from something that's configurable. So the best way to do that, let's see. What's going to be the best way to do that? The best way to do that is to say that on a character class basis, we are going to translate this amount of this stat into this resource. So at the character class level, I want to be able to say that I have a multiplier of 10 for intellect for the mana resource. So to do that, we'll actually need a new class called a resource contribution node so that we can serialize this property. And the resource contribution node will basically contain the name of a power resource, the stat, and the multiplier per level. Okay, that'll be an interesting one, so let's do that. So at the character class level, we need a resource conversion node. So this will be a new class. It'll be system.serializable, and it'll be a public class. What do we want to call this one again? It's the resource it's the stat to resource node. Yeah, that's good. Okay, so we'll have a stat to resource node, which will have a serialized field called PowerResource name. So private string PowerResource name. And we'll add a tooltip to that, and this is the resource that will have its maximum amount increased by the stat. Okay, and then we'll also want a tooltip and another field. And this one will be a private, let's see, so we've got the resource, and then we want the stat, and then we want the amount. Let's make this one the amount. So in this case, it's actually a conversion factor. So let's see, we want basically resource per stat. Resource per stat point. Let's just set the default to 10. The amount of the resource to be gained per point of the stat. All right, and then we need the stat itself. So will set a tooltip on that, and this will be the stat to convert to the resource. And this will be a private string stat name. We actually have, I think, something called like primary stats already. We have something called stat buff type here. And I'm just going to set it to intellect by default. Yeah, this is a bit of a shortcut to avoid having to perform some sort of lookup at this point. Technically, you could choose movement speed and convert movement speed to a resource, which is kind of weird, but I'm going to allow it just because it makes doing this a little easier. So now we have a way to actually make the conversion. So then we need on the character class like a list of stat to resource nodes. Let's make a header here. Call it stat amounts. And then we'll make another header here and call it, I don't know, stat conversion. And in the stat conversion, we will have a new serialized field with a tooltip above it. And the serialized field will be a private list of stat to resource node. And we'll just call it, sure, stat to resource nodes, and it's a new list of stat to resource node. And this will be conversion amounts for translating primary stats into resources. And actually, you know what? Let's take the weapon skills list here. And put the armor class list and the weapon skills list under capabilities, I guess. We'll make a new header called capabilities. I can change that at some point. Ability names and trait names. Ability names and trait names are, let's see, physical capabilities. Just call it abilities and traits. Capabilities, power resources, great. So power resources, we've got stat amounts, stat conversion. Let's put the power resources down there because it actually is basically makes a lot more sense to be down there. So first we'll do the stat amounts, then we'll do the power resources, then we'll do the stat conversion. Okay, that's better. And let's just let this compile, and it'll give us a bunch more errors. And let's go off and try to fix some of them. Okay. So my max mana. Here we're calling on mana changed. You cannot rename this element. Okay, that's neat. Public void on mana changed. Can I rename it now? I can rename it now. Okay. We're going to call this on resource amount changed. I don't know what this unresolvable conflict is, but we're just going to apply it and deal with the conflict. This will be int max resource amount. And this will be int current resource amount. We'll apply that. And mana percent can be renamed to resource percent. We're just going to leave mana slider for now, and mana text for now. Those are basically just like field values, so I don't really care about that. Like in the inspector where we're pulling in text and stuff. Okay, I don't think I actually fixed anything there. So this shouldn't say on mana change, this should say on resource amount changed. And okay. Here we need to grab the primary resource. Okay, so what we need is in character stats, we need to grab my max primary resource and my current primary resource. So let's go to the definition of that. We will rename my max mana we'll rename that to my max primary resource. And let's see, here we need to perform a calculation to figure out exactly what is the max amount. So we need to know what our primary resource is. I'm just going to basically return 0 in the default case. Assuming we don't have a primary resource, we should just be returning 0. So if PowerResource dictionary dot count is greater than 0, then we want to get essentially the item that's at 0. No, we want to get the character classes first resource. Okay, so let's actually get the character classes first resource first. So if and I don't know if we even have a reference to that. We do actually. If base character dot my character class let's see actually, if base character does not equal null and base character dot my character class does not equal null, then if base character dot my character class dot power resource list dot count is greater than 0, then if our actually also we need to know that our power resource dictionary dot count is greater than 0 as well, and then we can check if our power resource dictionary dot contains key, and we want the power resource list element 0. Then finally we can grab the calculation. So we want the power resource dictionary using this key here. And actually we want the max amount. So we're not even going to grab that from the power resource dictionary. The max amount is the amount of contribution that we get from our max primary power resource. So for that, we actually need to find let's see, in the character class, the stat to resource nodes. So I think we actually need a function here to make this a little easier, basically, because we've got a bunch of stat to resource nodes. And essentially what we want to do is query them and say, if my character has X amount of this stat, what is the amount of resources that I should get back? Okay, so we totally do need a function for that. So let's make one. This will be a public float get resource maximum. It will accept a float character level, I guess, and a PowerResource. And it will also need to accept let's see, stat buff types, I guess. So what we want to do basically is we'll run a for each loop, and for each basically look through each of those nodes. So for each stat to resource node in stat to resource nodes. And if here we need to basically check if it matches the power resource. So if, I guess, which means we need to expose these things. And I actually want to expose like the name, like the actual power resource. So to do that, I think I actually want to run through my list of stat to resource nodes on startup and get references to the power resources. Now, interestingly enough, I'm just sort of realizing here that stat to resource nodes and power resources are almost overlapping a little bit in behavior here. So this basically is a list of power resources. But I mean, there is the potential that you could have like two stats contribute to a power. For example, the way in some games you have like one agility and one strength will contribute each to the power. So let's actually keep this like that for now. That's fine. But for each stat resource node, okay, this means we actually need to go through the list of them. So we'll run a set Up Scriptable Objects call on this. We'll go stat resource node dot setup scriptable objects. And basically that's this function right here. And we will allow it to grab some references to the power resource. And we'll actually do that exactly the same way we did here. And let's see, we don't need a new list. And here, basically, power resource name does not equal null, and power resource name does not equal string.empty. And here we actually need a reference to the actual private resource, so this will be a private power resource. So then we go power resource equals tmp power resource. Okay, and finally then we can expose the actual power resource, so encapsulate that. Encapsulate that. Encapsulate that. All right, now when we go to get the resource maximum, if our stat to resource node dot power resource is the same as the power resource that we are asking for, and let's see. I think we need to send in character stats just so that we can go grab the contributing stat directly. You know what I'm going to do? I'm going to make this actually a lot easier. This is going to be sort of ugly and hard-coded for now until I actually implement stats as their own thing. But basically, let's send in the character stats, and we need a return value, so we'll set a float return value equals 0f. And I'm going to set this to resources per stamina point. We're just going to remove that from there. Okay, so we're just going to do basically resources per stamina point, resources per strength point, resources per intellect point, and resources per agility point. And then here we're just going to go return value plus equals, and this is going to be stat to resource node dot, then we need to expose these properties here. And then now that those properties are exposed, we can do resource per stamina point multiplied by the character stats dot my stamina. Okay, great. So actually in this case we don't even need the character level, because basically we're just grabbing the stamina directly from the character stats. So I think we're safe to just actually even remove that. Okay. And then basically we can do that for all four stats. So resource per strength point times character stats dot my strength. Resource per intellect point times character stats dot my intellect, and resource per agility point times my character stats dot my agility. Okay, so now basically we should be able, and here actually we want to return the return value. We should be able to query this thing and ask it what is the resource maximum for any particular resource. And let's see if I can find the code that's supposed to be calling that. Okay, here. So we don't even need the PowerResource dictionary. My max primary resource. The primary resource is determined on the character class. So return base character dot my character class dot get resource maximum for sending in the PowerResource of PowerResource list 0, which is the character's primary resource, and the character stats, which is this. And we need to return an int, so we're going to cast that whole thing to an int. Otherwise, we will just return 0. Okay, wow. Nice. So now finally we have an int that tells us the maximum amount of the primary resource for that character based on the character stats. Awesome. Now we need one for my current amount of that. I think we actually expose current mana as like a public float, maybe. Oh, you know what? That's actually coming out of character stats. Okay, so let's go back to this code right here and find right here. So we have my max primary resource, and then we have character stats, and we basically need my current primary resource amount. So let's go to the character stats, and here in character stats, we are grabbing my max primary resource. Let's actually rename that just to max primary resource. We will call this one my current primary resource. And this is where we actually need to check the dictionary. So we are going to return the PowerResource dictionary using the PowerResource list 0 as the key and just the value that's stored in there. So basically that PowerResource dictionary we created earlier will store the amount of that resource we have and then just return it out of the dictionary. Okay, great. So now that that's done, let's go check. We got some more errors down here. Use mana. This should be use resource. So we're going to rename that. And we'll call it use PowerResource. And we'll rename that to int used resource amount. And why don't we call that use primary resource for now? I'm not going to deal with secondary resources yet. I will add that in a different episode. For now, we'll just deal with primary resources. So we need to get my primary resource. I don't think I actually expose that. We actually expose the amounts of it, but not what it is. So let's expose a public power resource called primary resource. This will be a get only. It'll be a property, and we're just going to return null by default. And if our base character and our character stats and our primary resource list.count is greater than 0, then we just want to return the PowerResource list 0. Otherwise, we will return null. Perfect. And then, so actually what I can do here is if primary resource equals null, here we just basically go if primary resource does not equal null. And then we don't even need to do that check right there because that's already included in the other one. And for the current primary resource, same thing. If primary resource does not equal null, and we already performed that check, so here we actually don't even need to ask if the power resource dictionary, because basically we don't care. We're asking for the max amount, not the current amount, so we don't need to even query the dictionary. Okay, good. That code looks okay. So then primary resource, now that we've actually got that available and we don't have to do a bunch of checks, we should be able to use that in our code. So if our resource dictionary dot contains key primary resource, then our power resource dictionary at the key value for primary resource is going to minus equal the used resource count. And then it's going to equal the mathf.clamp right here. So basically, let's just replace that and replace that, and then put that in here. Perfect. And then here we will call on mana changed. What did I rename that one to? So we'll change this to on primary resource changed. Let's just see, was I using that anywhere else? I thought I already did like an on changed method for it. Set mana. Use primary resource, no. Mana change notification handler. Reset mana. Okay, no, I didn't. All right, so on mana changed will be renamed to on primary resource amount changed. And then we will call on primary resource amount changed. Sending in max primary resource and current primary resource, and I'm just going to rename that. Okay, good. Then here, I'm going to rename that to set primary resource. Amount. And I'm going to rename that to new amount. And this is kind of interesting because it's actually adding it, it's not setting it. So I guess what we need to do is basically this kind of code right here. So we'll set it to plus equals the current amount, or the new amount, and then we will clamp it. To the max primary resource value. And then we'll perform the notification. Okay, good. And then we have this mana change notification handler. I'm going to rename that to primary resource amount change notification handler. I know that's quite a mouthful. So here we'll basically need to be doing the same sort of dictionary check to make sure that we're okay. And we're just going to be directly setting it. So let's see, equals mathf.clamp, the current value, or that value I mean, between 0 and max primary resource amount. And basically what this does is it allows to cap the resource amount if the resource cap has been lowered due to stat, debuff, etc. Just so it kind of makes sense exactly what this thing is trying to do here. looking for max primary resource and current primary resource, we also send out that notification. Perfect. Okay, good. And let's see what else we got here. And basically we want to perform this check as well and just make sure that we have the dictionary down here. So reset mana, first we're going to rename that to reset primary resource amount and apply. Then we'll perform the dictionary check, set the current value equal to the max primary resource value, and then send out the notification with the current amounts and the max amounts. Okay, good. And quite a few hard-coded assumptions with regards to mana in the engine. And it's actually really cool to be getting rid of those. So here we have current primary resource. And let's see what this check is right here. Out of combat regen. Okay. Right here, we have this IEnumerator. And basically this IEnumerator is performing like out of combat health regen. And we are regenerating the mana amount every second with this. So we actually want to change this. We realistically only want to regen the health amount. For the regeneration of the other resources, we actually want to handle that directly through character stats. Like what I'm going to do is I'm going to give character stats an update loop and give it a chance to perform regeneration individually on each of its methods. So let's see, do we have update in here? We do not have update. Okay. I don't think. Yeah. So character stats now needs an update method. And what we'll do is we'll ask it to update the primary resources. Actually, no, we'll just ask it to update everything. Perform resource regen. Actually, why don't we make that protected? Okay, so for performing resource regen, we basically need to keep track of the tick rate. Here, I think I actually want to update this. Here we have regen per second and combat regen per second. I want to change this actually to regen per tick and combat regen per tick, and then actually set the tick rate. So to do that, we'll make a new float and call it Tickrate. And we'll make it 1. So every X seconds perform the regeneration. And this is going to be regen per tick. And combat regen per tick. And then rename this to combat regen per tick, and rename this to regen per tick. Let's apply that, and now we can basically go through we're going to want to go through the dictionary. So for each, and here we're going to get PowerResource in PowerResource dictionary.keys. Without those method signs. Okay, good. And then we want to perform the regen on them, which means that we actually need to keep track of our current tick rate. So for that, we'll actually need a second dictionary. I could do something here, like I could stick like a node in here that contains some information like the current value and the current tick, like elapsed time. But I'm just going to do this the easy way for now. So we'll just create a second one. PowerResource tick dictionary. Okay. So if PowerResource tick dictionary dot contains key PowerResource, else, and is that a float or an int? Because it needs to be a float. Good, it's a float. All right. Otherwise, we're going to add to PowerResource dictionary, and we were going to add the PowerResource with a value of 0f. And that's just starting the timer. If it does exist, then we will call the PowerResource tick dictionary based on the PowerResource, and we will set its value plus equal to time.delta time, because we'll be doing this every update. And we need square brackets here. Okay, good. And if this value is greater than the PowerResource.Tickrate, and I need to expose that. So we'll go into PowerResource here. We'll expose Tickrate. Then what we want to do is we basically want to take this number and we want to subtract it by the tick rate so that we don't lose the leftover time. All right, and then finally we will actually want to go perform an update. So here we know if our character is in combat. So if our base character does not equal null and our base character.my character combat does not equal null, and let's see, our base character does not equal null and our base character.character combat does not equal null, and our base character.character combat.in get in combat is true, then we'll perform combat regen. Else we'll perform out of combat regen. So here we're just going to basically set the value to plus equal PowerResource dot combat regen per tick. Else it'll be PowerResource combat tick. And then we actually want to mathf.clamp this, because what we could do is we could actually have like a resource that actually, like with Rage, for example, we could actually set the out of combat regeneration for Rage to like -3 per second, right? Which would actually make it like reduce. So we basically want to make sure that this is not going to go down below that value. And in fact, actually, just so that those notifications can be performed, we actually need to do this a little bit differently. We actually need to call set primary resource amount. And here we actually do check to make sure it's not going down to 0. Perfect. So what we'll do is set primary resource amount. No, you know what? That's primary resource. We actually need to just set resource amounts, like all resource amounts. And I think we'll still call the same function. So I don't know why this line is duplicated here. Yeah. So basically let's do code kind of like that. And Here, I think in order to centralize this, this is combat regen per tick as a float, so we'll do float used regen amount equals 0f. And then we'll take the PowerResource dictionary. This will just be used regen amount. This will be used regen amount. And actually this is out of combat regen per tick. Which apparently I didn't expose yet, so let's go expose that. Oh, regen per tick. Yeah, okay, it is exposed. Regen per tick, okay. Then we're going to plus equals the used regen amount, and then we are going to clamp it between 0 and here is actually where we need to get the primary or the resource max amount. Okay, this is notifying on primary resource, but for now we don't have multiples, so it's okay. This will need to be fixed when we add secondary resources. Good, so we still need this max value. And here we can already call this. So I'm just going to basically copy and paste that code out. And then just call it directly there. And to clean this up a little bit, let's just return those to the next lines. Okay, so we're going to mathf.clamp between, or this resource to the maximum resource list, and this is actually PowerResource. Okay, excellent. So this should perform in combat and out of combat regen, and it should actually work for negative values as well. Which means that we can now go back to character combat. We can remove all checks for mana, and we can remove the mana amount, and we can remove the call to recover mana. And let's see how many broken references we have left. So this is the character panel. So here we'll just call current primary resource, and here we'll call max primary resource, and for the title here, we'll call the character stats primary resource name, basically. And then that way it'll just display whatever it is, rage, mana, health, etc. Okay, that is better. So now we have a few more issues to fix. Okay, so now we need to do ability cost based on these resources. So base character dot character stats dot my current current primary resource. I think I actually coded a check for that already, I think. Maybe I didn't. Okay. Oh, maybe I did an ability. There we go. Perform power resource check. And this goes in the ability manager. And actually, we don't want to stick this in the combat log, because this is only for people. So if not perform what is it, the resource check? Perform power resource check on ability. Then we're just going to return. And if ability let's see, this is, I think, use primary resource. And we want the resource amount, so that'll be ability dot my amount. Get resource cost based on the iAbility caster, which is this. And we want to return an int. Okay. And if ability dot get resource cost this is greater than 0. Okay, great. Then we're going to use the resource. All right, let's see what else we got to change here. 5 more issues. So not enough. And here we actually got to change this. Primary resource ability dot PowerResource dot myname. Not enough of this resource's name to perform ability dot myname at a cost of ability dot get resource cost, sending in an ability caster, which is this. Okay, we can save that, hop back out, see what other kinds of hard-coded assumptions to mana we have. While initializing my name as a character class. What exactly name properties do we have? Oh, that's why, because this is a stat resource node. Psh. Yeah, okay. Well, initializing, and we'll put stat resource node. Okay, change that message, fix that, and let's see, a couple more issues to solve. Oh, this is neat. Current mana. We now need to save current resource amounts in the AnyRPG save data. Let's go to the definition of that. And here we have current mana. We actually need a list of resource save, resource power save data. In order to save this. So we'll make a new serialized property here called public struct resource power save data. The resource is my name, and the float is the amount. Basically, that's it. That's all we need. So then we need to make a new property called resource power save data. Resource power save data. All right, and we can no longer set current mana. That's now part of a resource power. Okay. That's going to break some stuff because we're going to try to save mana and that doesn't exist. So here we need to run a for each. Basically, I'm going to do it the same way that we do our quest data. I'm going to save resource power data. And so we'll go to where we save the quest data, go to the definition, and that's a little more complicated than we need, but we can strip out all the code. So we need save resource power data. And for each let's see what we want here. We want the dictionary keys, right? Yeah. For each resource power, for each power resource in player manager.myInstance.myCharacter.myCharacter character stats dot, and I don't think I actually exposed that dictionary, so let's make sure we're exposing that. See if I can find character stats here anywhere. There. Okay. And we need to expose the power resource dictionary. So quick actions and refactoring, encapsulate field, and save that. And then we will make a new save data. New save resource power data. There we go. And this is a new save resource power data. Resource power save data. And then we'll set the resource power data dot my name is equal to the power resource dot my name, and the resource power data dot amount equals power, and actually we want the dictionary here, not the power resource node. So we're grabbing the power resource. Okay, great. And now we can get rid of all these other lists here because we don't need them. And we will add this to the resource power save data. And we will add this new object, which was the resource power data. All right, that looks good for saving resource power data. And now we will want to load resource power data. So really interestingly enough, I don't think we ever actually load the mana amount. Cute. There we go. We actually do. Okay, perfect. So right here. So we will call load resource power data on AnyRPG save data and for that we'll go down to where we have load quest data right here. We'll make a new method called load resource power data. And let's see, for each resource power save data, resource power save data in AnyRPG save data dot resource power save data. And then here we actually need to set these amounts. So for that we need player manager.myInstance.myCharacter.my or character stats dot and let's see, I think we need to actually go through the dictionary and find these things. So you know what, let's actually just make a method. So we have a set primary resource amount, and I think I'm just going to do also set resource amount. So we're going to send in the resource name, which is going to be resource power save data, and we'll send in dot my name, and then resource power save data dot amount, and then we'll actually need to go in and write that function. So let's go ahead and make this function right here. So we have set primary resource amount. Let's go into character stats and we will make a new function called set resource amount. So set resource amount will be expected to accept a string and then a float. So we'll have float new amount and string resource name. So here we actually need to check for the resource name. So we actually need to get that from the system dictionary. So what we'll do is we'll create a new power resource, tmp power resource equals system power resource manager dot my instance dot get resource based on the resource name. And here we can go, let's see, if, tmp power resource does not equal null, and power resource dictionary contains key tmp power resource, then we're going to set these and this I think is get max resource amount. Get max resource amount was tmp power resource dot get, no, where did I put that again? Let's see if I can find this. I need to fix the formatting on this too. Control K, Control F will fix that. And we're going to call on primary resource amount changed. Yeah, I think that's okay. So here, where are we going to get the max resource amount? There. This is where we can just send in this to get the max resource amount. So basically that's exactly what we'll do. Just to make this a little easier to read, we're going to put these on new lines and then grab the resource maximum, sending in the tmp power resource. Okay, good. So now we can set the stat amounts when we're loading the game. So it says character stats doesn't contain a definition for set resource amount. And that's because this needs a capital A. And actually, you know what? Why don't we just rename that? Because that one needs a capital A as well. And we'll check if we have any more issues here. Okay, so this is kind of a neat use case. We have a mana potion. This is a really neat use case. Mana potion, technically as a class, actually needs to become power resource potion, we should be able to recover mana, we should be able to recover rage, we should be able to recover anything. So I think we actually need to change all that. So this is going to become PowerResource Potion. And we'll call this PowerResource Potion. We'll actually need to rename the file Mana Potion. We'll call it PowerResource Potion. We can have energy potions, rage potions, anything we want really. Let's load that up, and then we need to rename this as well to PowerResource Potion. Okay, great. So then now we actually need a power resource to expose that. So we'll put a header in here and a new serialized field called a private string, and the string will be the power resource name. And we'll put in a tooltip. The power resource to refill when this potion is used. And then we will actually need to add an override. For set up scriptable objects, and then we'll need to actually make a reference to the power resource. So private power resource. Okay, now we need to actually get a reference to that. So we already get references to power resources in character class set up scriptable objects. So we'll just copy this code literally directly out of there, and we'll pop it in there. And actually that needs a lowercase p. Perfect. So now, and actually we can add my name right here. Well, initializing plus my name. Okay. Now we have a reference to the power resource. So here what we want to do is get the character stats dot power resource dictionary. Oh, here, actually this is perfect. We can just do perform power resource check. No, you know what? Because that'll check for an ability. Okay, so we actually need to do like a get power resource amount and get max power resource amount. So let's go ahead and do that then. It's going to be the best way to do that. Just add some functions, I think. So let's add a public void get PowerResource amount, sending in a PowerResource, and actually this is going to be a float. So if our PowerResource dictionary dot contains key PowerResource, then return the PowerResource dictionary amount, basically. So PowerResource dictionary PowerResource. Else we're just going to return 0f. Okay, and we need to do the same thing for the max amount. So get PowerResource max amount, and here I think we actually want to call PowerResource.get no, maximum amount, no. This is actually going to be based on our character level. So we will return this one. Base character dot my character class dot get resource maximum based on PowerResource. And we can just return this directly. Oops. Okay. Now we can return the amount and the max amount. So basically dot get PowerResource amount for the PowerResource is less than get max PowerResource amount for the PowerResource Okay. So in the case of the mana potion, this was actually a castable item. And the castable item can actually technically do anything. Doesn't have to necessarily be mana, so we don't really need to fill out the logic for this at this point. We can basically just sort of ignore that for the most part, as long as we have a spell that's capable of actually performing an amount on a resource, it would theoretically be okay. Wow, and finally all the errors are fixed. Now, I have no idea if that's going to work or if it's going to have crashing or anything like that. So let's just give it a spin. Press the play button and see what breaks. That was a fairly tremendous change to the code base, so I expect that there will be a considerable amount of tweaking to get that to work properly. Ah, there we go. Okay, load button doesn't work. Yeah. That's really interesting. We're actually trying to handle auto attack on disabled units. We also couldn't find the power resource mana or energy. So that's kind of interesting, that we couldn't find the power resource Rage while initializing Warrior. Because we shouldn't have had any problem pulling it out of there. And character combat should have never run its start method because the characters in the preview window should have had that disabled. So I think what I'm going to do is I'm going to go investigate these issues offline, and I will come back when I figure out exactly what they are, and then we'll continue with basically changing the colors on the health bars, on the resource bars, so that we don't have blue resources, we have like red resources. So as always, I hope you enjoyed that. If you did, don't forget to thumbs up the video, subscribe to AnyRPG YouTube channel, or just leave a note in the comments, and I will see you in the next episode with the completion of this Rage Energy Mechanic Edition.